This lesson is about the Pythagorean Theorem. We're starting a unit on trigonometry, which literally means the measurement of triangles. So the Pythagorean Theorem is the first step in that. So the Pythagorean Theorem says in a right triangle, which is a triangle with a right angle, you've got to see that right angle marked in there, a squared plus b squared equals c squared. Now sometimes you look at that and go, well, what does that even mean? So I like to think of it in words. Leg squared plus leg squared equals hypotenuse squared. So the legs are the two sides right next to the right angle, and the hypotenuse is the long side. It's the side across from the right angle, and the hypotenuse is always C. The hypotenuse is always the one that ends up by itself on one side of the equation. So this kind of looks weird. Why are these squared? What exactly does this mean? So I've got an illustration here in the form of a video that shows you what this theorem is telling us. So what's going on in this video is you've got your right triangle right here, and on each side of the triangle there is a square. So the area of that square is the side squared. So if this side is A, then this area of this square over here would be A squared. And if this side is B, then the area of this square right here would be B squared. Across from the right angle right there would be the hypotenuse, so this side would be C, and the area of that square right there would be C squared. So what this video is going to show you is that these two areas right here, if you add them together, will exactly equal the area of this square. So what has been done is these are filled with water, and we're going to show you that these two added together is exactly equal to that one. So look at that, exactly the same. You can go the other direction. Exactly the same. So that is what the theorem says. So what we do with the Pythagorean theorem is if we have a right triangle and we know how long two of the sides are, we can use it to figure out how long the third side is. When you're using the Pythagorean theorem, it's really important to make sure you know which side of the triangle you're trying to figure out. So I like to look at the triangle and label the three sides as legs or the hypotenuse. So I've got my right angle right here. The hypotenuse is always going to be across from that. So this side right here is the hypotenuse, and these two are the legs. Now, it doesn't matter which leg is A and which leg is B. I just think of the Pythagorean theorem in words. Leg squared plus leg squared equals hypotenuse squared. So in this case, I have 8 squared plus 15 squared equals C squared. So grab your calculator if you don't know your perfect squares, and we'll go ahead and do some math here. So make this stay in front. We've got 8 squared, 64, 15 squared, 225 equals c squared. So I need to add those two together. So 289 equals c squared. So how do you undo a squared? How do you get rid of squared? Well, the opposite of squaring something is to take a square root. So if I want to figure out what c is, I take the square root of 289. Come on. So square root of 289 is 17. So the hypotenuse here is length 17. Now, one thing that you should always keep in mind is the hypotenuse should always be the longest side of the triangle. So here I want to make sure that my answer is bigger than both 8 and 15, and it is. 17 is longer than 8 and 15, so that's good. Make sure the hypotenuse is the longest side in the triangle. That's a good way to just double check and make sure you didn't make a mistake somewhere along the line. So let's look at an example where it's one of the legs that we're trying to figure out. So if I look at this one, my right angle is right here. So the side across from that, the 13, is the hypotenuse. So these other two are legs. So I've got leg squared plus leg squared equals hypotenuse squared. So it doesn't matter what order you write them in, but I'll write a squared plus 5 squared equals 13 squared. So 5 squared, 5 times 5 is 25. 13 squared is 169. Now I want to solve an equation. So if you're trying to solve an equation, you want to undo things in reverse. My goal is to figure out what a is. So I need to get a by itself. So first I need to get rid of a plus 25. So I need to do the opposite of adding 25, which is subtracting 25 from both sides. So that will leave me with 144. And then I need to do the opposite of squaring something. To undo the square, I take a square root. And what do you square to get 144? Well, 12. If you weren't sure, you could type it into a calculator. There's your answer. A is 12. And we can double check, make sure the hypotenuse is the longest side. 13 is longer than both of those. And we've got our answer. So these two examples that I've given you, all of the sides had whole number lengths. Now, the next examples I'm going to give you, the sides do not have whole number lengths. On your homework, you're going to be asked to either write the answers as simplified square roots or to write them as decimals. So I'm going to remind you as we go how to do that. Now, I am not going to do every single example on the notes, but you can print off the filled in notes if you need to see more than I do on this video. So first, let's look at example C on the notes. So example C has a triangle, and it's got sides of 9, 14, and C. And the side across from the right angle right here is C, so that's the hypotenuse. and the 9 and the 14 are legs. So leg squared plus leg squared equals hypotenuse squared. So it doesn't matter whether you write 9 squared or 14 squared first. And hypotenuse is c squared. So 9 squared is 81. 14 squared is 196. So 81 plus 196 is 277. So I need to take a square root of that, and I want to think about, does the square root of 277 simplify? So I want to think of, well, is there anything I know that 277 can be divided by? Well, I know 2 doesn't go into it because it's not an even number. 3 doesn't go into it. 5 doesn't go into it because it doesn't end with a 5 or a 0. Can't be divided by 7. It couldn't be divided by 3, so it can't be divided by 9. 11, no. How about 13? No. 15 won't work. How about 17? Nope. Okay, and once the number down here gets smaller than the one you're dividing by, if you've already gone up in order, you're done. So this is a prime number. 277 is a prime number. That means I'm not going to have any pairs. That square root doesn't simplify. So if I want to write my answer as a square root, that's the answer. Or if I'm asked to write it as a decimal, I just go ahead and type this in. It's about 16.64. I think on the homework it just asks for nearest tenth. So those are just two different ways of writing the same number. Square root of 277 and 16.6 are the same number, just two different ways of writing it. And you can see 16.6 is longer than 14. So the hypotenuse is the longest side on that triangle. So it looks like there's not a good reason to think that we made a mistake or anything. So it looks good there. All right, I'm going to go backwards. I'm going to look at example B. So this one, I have 15, 20, and B here. And the side across from the right angle is 20. So 20 is the hypotenuse. And the 15 and the B are legs. So leg squared plus leg squared equals hypotenuse squared. It doesn't matter which one you put in first. If you want to write 15 squared plus b squared equals 20 squared, that's fine. If you want to write b squared plus 15 squared equals 20 squared, that's fine. What's important is that the 20 squared is the one by itself over on this side, because the hypotenuse squared needs to be by itself. So 15 squared is 225. 20 squared is 400. So now we have an equation. We need to get b squared by itself, so we need to subtract 225. So notice, anytime that you're trying to find a leg, you end up subtracting. That's a pattern you're going to see. Anytime you're looking for a leg, you're going to end up subtracting. So b squared is going to end up being 175. And I need a square root. So this is an example where this square root can be simplified. So if you don't remember how to simplify a square root, what you want to do is make a factor tree for 175. Think about what goes into 175. Well, it ends with a 5, so it can certainly be divided by 5. So 5 times 35, and 35 is 5 times 7. So what you're doing here is you're looking for pairs. What you're saying is that 175, square root of 175 is the same as the square root of 5 times 5 times 7. And you can break that apart and say, well, that's the same as the square root of 5 times 5 times the square root of 7. And square root of 5 times 5 just means, well, what do you multiply by itself to get 5 times 5? Oh, you multiply 5 by itself to get 5 times 5. And the square root of 7, there's nothing you multiply by itself to get 7, it's just 7. So this is a long way of writing out work. I usually don't write out this much work. What I usually do is just say, oh, look for pairs. Oops, sorry. If I see a pair, I cross one out and I know the other one comes outside the root. But this is why. You're saying, oh, well, here's a pair. The square root of 5 times 5 is 5. And then the 7 is left over. So b here is 5 square roots of 7. I could also get a decimal. So let me show you that that is actually 5 square roots of 7. And a decimal would be about 13.2. So 20 is the hypotenuse, 20 is the longest side there, so looks good. Next example I am going to do is a little bit trickier. We're going to look down at the very bottom. We're going to look at example I. So the reason this one is tricky is because we have something that already has a square root in it as a side. We have a side that has a length of 3 square roots of 2. And that can be a little confusing, but the formula is still the same. So the square root is right here. The side across from the root is x. So x is the hypotenuse in this case, and the other two sides are legs. When the side isn't labeled A, B, or C, it's really important to think about whether it's the hypotenuse or one of the legs. Let's go ahead and write down our equation. Leg squared plus leg squared equals hypotenuse squared. It is very important when you have something like 3 square roots of 2 squared that you put it in parentheses. If you leave off the parentheses, you're going to get the wrong answer. So we have 3 square roots of 2 squared plus 6 squared equals x squared. So let's just think about what that means. 3 square roots of 2 squared means 3 square roots of 2 times 3 square roots of 2. So 3 times 3 is 9, and the square root of 2 times the square root of 2 is the square root of 4, which is 2. So 9 times 2 is 18. So let's just show you that that's what you get if you type it correctly with the parentheses. It is 18. Now, if you leave the parentheses off, the calculator thinks that you only want to square the square root of 2, and it will give you 6, because it didn't square the 3. It only squared the square root of 2, but not the 3. So it just did 3 times the square root of 2 times the square root of 2. It didn't multiply in the other 3. So be careful. So this is 18. It's not 6, it's 18. 6 squared is 36. So 18 plus 36 is 54. All right, so let's go ahead and make a factor tree. So 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. So I'm looking for pairs. The square root of 3 times 3 is 3. And then there's no pair for either of these, so they have to stay under the square root. Square root of 3 times 2 is just the square root of 6. So that's what x equals. And you can see here that that is what you get. If we want a decimal version of that answer, that's about 7.35. So again, what I did right here, if you got a little lost, I was saying this is equal to the square root of 3 times 3 times 3 times 2, which is the same as if I take a pair, square root of 3 times 3 times square root of 3 times 2. So the square root of 3 times 3 just means, well, what do you multiply by itself to get 3 times 3? Well, 3. And here there are no pairs, so I just multiply those back together to get 6. All right, so 7.35, that is the longest side. I think 3 square roots of 2 is something like 4.2-ish, so that's the longest. I know I'm skipping all over the place on your notes, but let's look at example F. It's another one with one of these square roots in the problem. The triangle is tilted on this problem, so it can make it a little tricky to figure out which side's the hypotenuse. And this is a problem where I see all sorts of mistakes when I put something like this on a quiz or a test. I often see people just say that x is the hypotenuse, but it's not. Here's the right angle. Across from the right angle is the hypotenuse. It's the 4 square roots of 5 that's the hypotenuse. So x is one of the legs. And the square root of 2 is the other leg. So make sure that when you're plugging into the equation, you're doing leg squared plus leg squared equals hypotenuse squared. It's got to be the 4 square roots of 5 squared that's by itself on one side of the equal sign. So I would probably usually put the x squared first, although it really doesn't matter. So x squared plus square root of 2 in parentheses squared equals 4 square roots of 5 squared. So square root of 2 squared, the squared cancels out the square root and you get 2. 4 square roots of 5, well, 4 squared is 16. The square root of 5 squared is 5. 16 times 5 is 80. If you're not sure, type it in with parentheses. I accidentally hit another calculator, so I'll close it as soon as it starts. So it is 80. If you type it without the parentheses, you get 20. And that is not correct. So 20 is wrong, 80 is right. It's 80. All right, so I want x squared by itself, so I'm going to subtract 2 from both sides. Again, if you're trying to figure out a leg, you're going to be subtracting. So 80 minus 2 is 78. Take a square root. Well, let's see. 78 can be divided by 2. That gives me 39. And 39 is 3 times 13. And those are all prime, and there aren't any pairs. So that means that that square root can't be simplified. X is just the square root of 78, or if I want a decimal, 8.83, 8.8 about. So if I wanted to figure out whether that was which side was the longest on here, I would need to get decimals for all of them. 8.9, and that's about 1.4. So the hypotenuse is the longest side. The last example I am going to do is problem H. So this one, the sides are given to you as decimals. So don't try to give me a simplified square root if they're given as decimals. Just give the answer as a decimal. Sometimes people get a little freaked out by seeing decimals. It's okay, just do the problem the same way you would any other problem. So across from the square root, we have the 11.9. So that's the hypotenuse. Did I say across from the square root? I meant across from the right angle. Sorry, my mind is in a million places at once. So the other two sides are legs. So leg squared plus leg squared equals hypotenuse squared. So we are trying to find a leg. So a squared plus 8.4 squared equals 11.9 squared. So again, make sure it's the hypotenuse that's over by itself on this side. So I'm definitely going to need a calculator here. I don't know what those are off the top of my head. So 8.4 squared is 70.56. 11.9 squared is 141.61. I'm looking for a leg again, and anytime I'm looking for a leg, I'm going to end up subtracting. So that gives me a squared equals 141.61 minus 70.56, 71.05. Take a square root of both sides. Don't try to make a factor tree or anything. It's a decimal. I don't expect you to make a factor tree or give me a simplified root. Just take the square root in your calculator and follow the instructions on your homework. Round to whatever it says. I think your homework just says nearest tenth. So that's about 8.4. All right, so A is about 8.4. Oh, hey, look, about the same as the other leg. And the hypotenuse is about 11.9. Hypotenuse is the longest side. We're good. So that's the last problem I'm going to do on this video, but the filled-in notes have all of the examples done in detail. So if you need more examples to look at, you can look at those. And I have also posted some other links to other places you can go for help if you need them. And feel free to send me an email if you want to schedule a time to get some help on homework. A little later on this week, I will post some times that I will be doing some homework help sessions so that you can get help if you need them.